You've seen them 1,000 times, right? Pigs and cows, two of the most common animals on any farm. But have you ever stopped to think about what they eat? Turns out their dinner plates are worlds apart, and the reason why is this incredible story about two completely different biological designs. I mean, look, at the end of the day, they both need the basics, right? Protein, fats, carbs, the building blocks of life. So what gives? Why are their diets so radically different? Well, the secret isn't actually in what they eat, but in how their bodies are built to handle it. And this, right here, is the big reveal, the absolute game changer. On one side, you've got the pig. It's what we call monogastric. It's a fancy word that just means it has one stomach, kind of like we do. But the cow, oh, the cow is a ruminant. It has this incredibly complex 4-part stomach that's less of a stomach and more of a high-tech biological factory. And that one single difference, well, it changes everything. So here's how we're going to break it all down. First, we'll look at the pig's simple, direct system. Then, we're going to dive into the cow's amazing internal factory. After that, we'll put them head-to-head to really see the different philosophies at play. And finally, we'll talk about why any of this actually matters. Sound good? Let's get into it. Alright, first up, the pig. We're starting here because, honestly, its digestive system is a much more straightforward blueprint. What goes in is more or less what the pig's body has to work with. There's no secret sauce, no magical transformations happening inside. So here's the most important thing to get about a pig. Its nutrition is direct. The building blocks for protein, these things called amino acids, well, there are 10 of them that a pig's body simply cannot make on its own. They have to be in its food, in the right amounts, or the whole system just doesn't work. 10, that is the magic number in pig nutrition. Think of it like baking a cake. If you're missing even one of those 10 essential ingredients, or you don't have enough of it, the whole recipe fails. You're not getting a cake. For the pig, this means the process of building muscle and simply growing grinds to a halt. Now, even within those 10, not all are created equal. You've got what nutritionists call the big four. These guys, lysine, tryptophan, threonine, and methionine, are the ones most likely to be in short supply, especially in common feeds like corn. They're called limiting for a reason. If you run out lysine first, it doesn't matter how much of the others you have. The whole production line stops. So getting these balanced is absolutely crucial. And check this out. This shows you just how precise this science has to be. A tiny little piglet needs a diet with about 1.7% lysine, but as it grows and gets closer to market weight, that need drops to less than half of that. It's not a one-size-fits-all deal. You have to constantly adjust the recipe to match the animal's exact needs at every single stage of its life. Okay, so that's the pig. Pretty straightforward, right? Well, get ready to throw all of that out the window, because now we're talking about the cow, where the rules of nutrition are completely rewritten. And here's the wild part. When you feed a cow, you're not just feeding one animal. You're actually feeding the trillions of tiny helpers living inside her. Say hello to the rumen. This thing is incredible. It's the first and the biggest compartment of the cow's stomach, and you can basically think of it as a giant 50-gallon fermentation vat. It's a living ecosystem, home to trillions of bacteria, protozoa, and fungi, and their job, to break down all the tough, fibrous plant stuff that a cow could never digest on her own and turn it into energy and high-quality protein. So because of this, a cow's diet is built around two different kinds of protein. First, you have what's called rumen degradable protein, or RDP. The name says it all. This is the food for the microbes. Then you have rumen undegradable protein, or RUP. This stuff is designed to literally bypass that fermentation party in the rumen and be digested directly by the cow herself. It's a very clever two-pronged strategy. So here's how this magic trick works. The cow eats its feed. The RDP part of the meal nourishes that massive microbial army. Those microbes grow and multiply like crazy, and in the process, they create their own perfectly balanced high-quality protein. Then this new microbial protein, along with that bypass protein, flows out of the rumen and gets digested by the cow. The cow is literally farming its own perfect food source right inside its own gut. It is amazing. So we have the two systems, the pig's direct blueprint and the cow's internal factory. Now let's put them head to head. This is where you can really see the two completely different philosophies for turning food into an animal. Yeah, the easiest way to think of it is this. The pig is a consumer. It needs its meal served up on a platter, perfectly balanced and ready to go. The cow, on the other hand, is a manufacturer. It can take in basic, raw ingredients and use its microbial workforce to cook up the perfect meal for itself. Here is a perfect, practical example of how these differences play out in the real world. A piglet's mother's milk is really low in iron, so almost every piglet born gets an iron injection to prevent anemia. It's just standard practice. Now, what about calves? Is this a routine concern for them? Nope, not at all. It's a direct result of their completely different biological wiring. And it doesn't stop with protein and minerals. That microbial factory in the cow's rumen is also busy synthesizing essential B vitamins and even vitamin K. The pig has no such ability. It is 100% reliant on its diet to provide those vitamins. The cow has its own internal vitamin production line running 24/7. So we've gone deep into the biology, which is fascinating stuff. But you might be wondering, why does this all matter outside of a science textbook? Well, it turns out it has huge implications for farming, for our environment, and for the well-being of the animals themselves. This is where the science really meets the real world. Getting this right, what we call precision nutrition, means we can be way more efficient, using fewer resources to produce our food and minimizing waste. It's also better for the environment, because balanced diets mean less excess nitrogen and phosphorus getting into our ecosystems. And maybe most importantly, it's about animal welfare. Providing deficiencies ensures these animals don't just survive, but they truly thrive. So we'll end on this thought. As we get better and better at understanding the cow's incredible internal world, are we moving towards a future where farming is less about just feeding an animal and more about carefully managing and designing the perfect microbial ecosystem inside of it? It's a fascinating question about the future of how we produce our food.